Okay, so question number 5. Is bromine trifluoride polar or nonpolar? So first let's write out its Lewis structure. That'll help us answer the question. So we need to find the total valence electrons of the molecule. So bromine has 7 valence electrons, and there are 3 bromine atoms. And for fluorine, there are also 7 valence electrons. So if we add this up, we get 28. Okay, so now let's draw fluorine as our central atom. Oh, sorry, it should be BrF3. And then let me just switch these two. Okay. So bromine is our central atom. And fluorine are, the 3 fluorines are the terminal atoms. And now let's draw out all of the lone pairs on the fluorines and count out to see how many electrons I've drawn so far. So each bond contains 2 electrons, and there are 3 bonds, and then each fluorine contains 6 electrons as the lone pairs. So far I've only drawn 24 electrons, and I need 28. So I'm going to add another 2 on my bromine atom. And now we kind of have this kind of shape. Kind of messy, so I'm just going to not circle them. But yeah, so this is a valid Lewis structure for bromine trifluoride. So now we just have to find out whether or not this molecule is polar. So first let's see the polarity of a bromine and fluorine bond. So let's calculate the electronegativity difference of bromine and fluorine. So let's find their values on this electronegativity periodic table. So bromine is 2.8, fluorine is 4. So what is this, like 1.2? Yeah. So their electronegativity difference is 1.2. So therefore this is a polar bond. And this is because the difference in electronegativity is greater than 0.5 and it's less than 1.67. So therefore, all the bonds are polar, and the fluorines are much more electronegative than the bromines. So there's going to be dipole moments throughout the molecule, and the shape with the lone pairs allows these dipole moments to not be cancelled out. So therefore, the entire molecule is also polar. And this is because dipole moments are not cancelled out. So let's see what the junior tutor said. Polarity refers to the charge separation, which causes the presence of dipole moment. Additionally, polarity can be viewed from the perspective of a bond or the entire molecule itself. A bond can be polar because the electrons are unequally shared between the bonded atoms due to their electronegativity difference. However, although a molecule has polar bonds, this does not imply that the entire molecule is polar. If the molecule's symmetry results in the cancellation of the dipole moments overall, the molecule becomes nonpolar. So they found that the bond of bromine and fluorine is polar because of their electronegativity difference. And then they looked at the shape of the molecule. So it is T-shaped. So since fluorine is the more electronegative atom, the dipole moment of each bond points towards fluorine. Due to this shape, the dipole moments pointing upward and downward cancel each other out, but the dipole moment pointing rightward does not have any counterpart that cancels it out. Therefore, it is a polar molecule, assuming this orientation. Yep, so this solution is correct.